So in this video we're going to be looking closer at the WalkTEM2. It's a transient electromagnetic receiver from ABEM in Sweden. This is a new iteration of the WalkTEM1 where there's been a few changes. Among others, the transmitter and separator has been separated in this unit. So now you have a receiver and a transmitter. The receiver is the one that has obviously all the sampling and everything, so we will look a bit closer at the interface and how your settings can be configured in there. This box here has a few inputs. You have USB 1 and 2, so you can put a keyboard and a mouse or USB storage onto that. Also Ethernet for connecting it to your office network for dumping data. There's a box connector here for your transmitter. So this is the interface cable between the transmitter and receiver. And nice little cooling ripple here. On the other side, we have the receiving channels. So there's two channels in the WalkTEM2. There's a channel A and a channel B. We can receive on similar antennas, multi-component. So you could do a Z component and a vertical component if you wanted to. You can also connect two different transmitter loops in a Z component, so you could have a 5-meter loop and the 200-meter loop connected simultaneously. Then there's an external input here for charging the batteries and also for just connecting external power for longer surveys. In here as well we have access for the internal batteries. So one of the new things with the WalkTEM2 is that it's using lithium-ion batteries. These are quite nice batteries. We've been working with lithiums for quite some years in ABEM for GPR applications, and it's good to see that ABEM is implementing that as well. It's a really good battery technology. These batteries are actually hot swappable, so when we turn on the instrument, if we wanted to charge a battery for a new one, we can simply take one out, put a good battery in, and hot swap on the fly. So that's a really neat feature that's going to benefit a lot of people. I'm just going to put the external power on now, and we'll go through and look at the interface. So in the meantime, if you're interested in powering geophysical equipment that sucks a fair bit of power with lithium ions, made another video where we go through this custom battery pack that we made, where we can have up to 200 amp hours of 12 volt sitting for field applications. So it's pretty nice to have 200 amps of 12 volts sitting in a little case like this. So the instrument WalkTEM2 here is powering up the software, and we'll go through and just have a look at a few of the menus in here. For those of you who are not maybe familiar with the history of the WalkTEM, it's essentially an airborne system which has been modified for ground applications. So most of this hardware and software is made in Denmark by Aarhus University Breakout Group, and they're kind of the specialists in time domain applications. So there's SkyTEM system is what it was called, the airborne system, which is mainly used for groundwater exploration, but also some minerals. So when we go through and look at the interface here, you can see there's a tab up the top here with the different menus, and these are all the configurations that are associated with our instrument. I'm just going to go and connect an external mouse here, so it just makes it a little bit easier. Sorry, while I reach over the camera here. When you attach this mouse, I don't have to get my hands into the image. So There we go. So in the first section here, we can put project names in and name new project categories. And every project is probably what you would consider a line if you are doing discrete soundings. So you have a project and then you attach soundings to that project. So it's kind of a folder, a system for managing your data. This also links in with the processing software that you use. So it links in directly with the software from Aarhus as well. So there's different scripts you can run. So you can have a dual moment script, which is basically one of the major advantages here with this whole Danish Aarhus University approach to time domain soundings. Time domain is really about getting a lot of depth, but also resolution. And if you crank out huge amps on huge loops, you won't be able to turn off that current very fast, and you lose surface resolution, because by the time that current is turned off, the signal will be tens or if not hundreds of meters in the ground already. So the kind of novel way of thinking of time domain for high accuracy applications is really looking at doing two measurements on a station. So you can do a fast turn off, low current or low moment measurement to sample all the near surface and get really good resolution in that area. And then you can switch across to the second moment, which is high current, slower current turn off, but a lot deeper signals. So that's the whole idea of this system, is to have the best of both worlds, basically. When you then go and do your inversion and interpretation of the data, you do what's called a joint inversion of those two simultaneous measurements on your station, and you get very, very good data. So this is one of the things that's unique about this system. So you can define different configurations here for your number of gates, how long your receiver is on, and all those types of things. Then you can define how many cycles you have in your measurement, and it'll show you here then defined on your total time series. Here it's 30 milliseconds, and your number of cycles, how long it's each measurement station is going to take you. Obviously there's provisions for different repetition frequencies. So in Australia we use 50 Hertz power lines, so we're going to use a 50 Hertz repetition here. Here's your parameters that decide by your script. So this is the on time, the off time, number of repetitions, and also your repetition frequency. So in your transmitter loop, you also have the option to choose different loops. So for shallow groundwater explorations, it's typical to use a 40 by 40 meter loop, but you can see there's a lot of different options for different loops. At the moment we don't have a transmitter connected to this instrument, but you would see your dampening resistor options here, and you can actually go in and analyze your waveform and plot your waveform live here to make sure you have the correct dampening resistor on there. That's a really cool thing, because normally when you select dampening resistors for your transmitter, you're kind of a bit in the dark. You're taking a wild guess really on what's the best to use for that site. Well, with the WalkTEM2 you actually get a really intelligent way to be able to look at that. So that is a very cool feature. For your receiver channels, you can determine then here what coil do you have attached. So there's two receiver coils available at the moment. There's an RC5, which is the 5 square meter effective area with a preamp, and then there's the larger coil, which is a 200 square meter coil. And you can also set which component is it sitting at. So obviously you're not going to take a 200 square meter wire coil and put in anything else than a Z component. you could try and get it up flying if you wanted to in one of the others. But whereas the smaller coils, you'd have a lot easier time turning them on an angle and getting those in the. These are offsets for your receivers compared to your transmitters. So if you are situated in the center of your transmitter loop, you would have those as all zeros. And the next tab up here, we're going into the measurement cycle. So in here, you get a lot of information from the previous page. So these are essentially your presets. These are your current measurement parameters. There is a GPS built into the handle of this unit, so it'll continuously get your GPS position, but at the moment we're inside, so we're not going to pick up a GPS position here. And you'll also see down here your TX values, what's the voltage, what's the current, and also temperature of that transmitter. As you receive data, you'll get your decay curves showing on this over here, and you can plot them all, channel A, all components, or channel B, all components. There's lots of different ways that you can show this data here. This gives you a very good quality control in the field. You can evaluate your noise levels, or if you have any fence lines or power lines or anything that's going to give you harmonics in your data, you'll be able to pick that up here and make decisions on either moving your station slightly to a side, or maybe do a couple of more measurements to reduce your late time noise. So for people starting out with time domain methods, it's sometimes very hard to actually evaluate if you are collecting good data or bad data. And this just gives a lot of confidence in what you're collecting is actually good. I remember when I started out with time domain, this was mid-90s, and we were using much older systems with just a 2-line numerical display where you had to evaluate from raw numbers or digits on a screen if you were collecting good data or not. And it was pretty hard to know until you get back in the office if you had been collecting garbage all day, or if it was actually good data. And with the visual representation, as you stack the data, you actually are in a much better position of collecting good data. So once we collect the data, you can go over and post-process your data. So you can see here, that's your project number 1, and we can actually go in and open that project, and we can in the field do inversions and post-process data on the spot. So that's also a really neat feature, to be able to actually do inversions on the instrument. And then we have some standardized setting configuration files for the instrument in your admin screen. So generally these are your settings that you have in the instrument. You have all possibilities to collect really, really good data with a fast turn off, very well controlled transmitter and waveform. And if you need a time domain capability, then the WalkTEM2 should be a really good option for you. If you have any questions on time domain or the WalkTEM2, feel free to visit us, the website marla.gpr.com.au, or just jump onto our website. Thanks for watching.